It's time to start, and I'm very happy to welcome you all to today's seminar at which Kieron Barclay will speak on the topic of when and where birth spacing matters for offspring outcomes, an international comparison. Kieron Barclay completed his PhD in sociology at Stockholm University in 2014, and the title of his thesis was The Long-Term Impact of Birth Order on Health and Educational Attainment. He is now Associate Professor of Sociology at Stockholm University and Research Fellow at the Max Planck Institute for Demographic Research in Rostock. He was admitted to the Professura Scientia program at SCAS in 2019. Before being awarded the Professura Scientia Fellowship, Kieron Barclay spent time at the University of Pennsylvania, at the London School of Economics and Political Science, and the Max Planck Institute for Demographic Research. But mind you, already as an undergraduate student, he studied abroad at the universities of Sussex, Oxford, and Tsinghua in China, where he studied Chinese language. As a research assistant professor at the London School of Economics and as deputy head of the Laboratory of Population Health at the Max Planck Institute, Kieron Barclay developed an independent line of research examining the intersection of health and fertility from a demographic perspective. As a Professura Scientia Fellow, Kieron's research is focused on the impact of the family of origin on health inequalities, taking a global, historical, multi-generational, and comparative perspective. The goal of this research is to develop a deeper understanding of how the family influences health inequalities, how this has changed over time, and the underlying factors explaining that variation. His research agenda is evidently deeply rooted in sociology, but also combines insights from demography, sociology, economics, the public health sciences, and history in order to examine how the importance of family conditions for child health has changed over time and with development. And in 2018, Kieron received the European Demographer Award for Early Career Achievements. Kieron publishes with proficiency. His interdisciplinary research has been published in leading peer-reviewed journals, including Demography, Population and Development Review, Social Forces, American Journal of Epidemiology, and Proceedings of the Royal Society B, Biological Sciences. And just to give you an idea, I'd like to mention 3 articles that appeared this year, 2021. One of them is called Sibling Similarity in Education Across and Within Societies, and this appeared in Demography. It's co-authored with several other colleagues. The second one I'd like to mention has the title, The Production of Inequalities Within Families and Across Generations, the Intergenerational Efforts of Birth Order on Educational Attainment, and it was published in the European Sociological Review and co-authored with Torkel Lyngstad and Dalton Conley. And thirdly, an article by the name of Do Income and Marriage Mediate the Relationship Between Cognitive Ability and Fertility? Data from Swedish taxation and conscriptions registers for men born 1951 to 1967. And this was published in the Journal of Intelligence and co-written with Martin Kolk. All in all, Kieron Barclay has an impressively strong record of academic citizenship and participation. He's a scholar who shares his research regularly and easily with colleagues. This is evident from the frequency with which he attends actively in conferences and workshops, and, as you can see, in the way he publishes with colleagues. And now we are all very keen to hear you, Kieron, speak on the topic of birth spacing. The scene is yours.
Thank you very much, Christina. I'm not sure if I can live up to that introduction, but I'm going to do my best. So thank you. It's very generous, as always. So thank you all for tuning in today. So this presentation title, you know already, When and Where Birth Spacing Matters for Offspring Outcomes, an international comparison. What I'm going to be trying to do is to summarize the findings and kind of integrate them into sort of a meaningful narrative from 4 or 5 papers that I've been working on. Some of them right now, still ongoing work, some of them published over the last few years. And of course also drawing upon scholarship of others in this field. To try and explain when and where birth spacing matters. So Christina mentioned briefly some of my previous work, and I just want to maybe give an outline of where this birth intervals research comes from. And it comes out of my work prior to coming to SCAS, where I was doing a lot of work examining how fertility behavior and fertility decisions made by parents affect outcomes for children, and also for themselves, in fact. So it's hard to say always decisions because people don't always choose exactly when they get to have children or not. But fertility behaviors like parental age at birth, how many kids people have, the spacing between births. I've always been interested in whether these have consequences for the children in the short term, medium term, and the long run, and also for the parents themselves. So, for example, parental age at birth and how many children parents have also seems to be correlated with their own mortality outcomes later in life. So this is where this birth spacing research comes out of, and I started this earlier and have continued it into the present, and well, we'll see how much I do on it in the future, I suppose.
Excuse me, we can't see the slides.
Oh, I forgot to share it. Sorry, I'm sorry. Well, luckily, thank you for stopping me. Okay, you can see it now, I hope. Is that a yes?
Yes.
Okay, yes. Thank you. Yeah, so you didn't miss anything. So when I'm talking about birth spacing, what I'm talking about is simply the space between childbirths. And so if you look at this simple diagram at the bottom, if these are, say, 3 children in a family, the first, second, and third born, I'm going to be talking about research, my research and other research, which looks at what I call the preceding interval. So that's the interval preceding, say, your own birth, the birth between your older sibling and yourself. So here it would be between the interval between 1 and 2 for sibling 2. And when I talk about the subsequent interval, I'm talking about the time until the birth of your subsequent sibling, your next born younger sibling. And it's worth mentioning here because it'll be relevant later that firstborn children, apart from in a very abstract sense, they don't have a preceding interval, and lastborns don't have a subsequent interval. And that has some consequences about how statistically the models can be estimated and so on. But yes, so this is what I'm talking about. Some research also examines the overall density of the sibling group. So say the amount of time between the firstborn and the lastborn and divide that by the number of siblings. And this is not something that I've been using myself very much, but if I mention that term, that's what I'm talking about. And if you want me to clarify any of these things or any other questions throughout the talk, just feel free to interrupt me. Okay, so I'll just give a brief overview of what I'm going to do today. I'm going to talk a bit about the policy relevance of looking at birth spacing. I'm going to talk about the mechanisms, not just biological and physiological mechanisms that affect birth spacing, but also social mechanisms within the family, and also the potentially very important role of selection or statistical confounding that might drive any association between birth interval length and offspring outcomes. And then I'll talk a bit about the data that I've been using to address these questions and summarize some of the empirical findings that we've been seeing across the US, Sweden, and a wide range of low and middle income countries. So of course I'm going to, because this is my talk, I'm going to give a lot more focus on my research, but if you have questions about some of the other stuff that's been, I'm going to mention it, but I won't go into it in as much detail, of course, apart from sort of providing background to what we've been doing. And then related to these kind of Can you see my mouse when I move it? You can? Okay. So related to this, these 2 points, looking at how the effects of birth spacing on offspring outcomes like child mortality vary as you look at Sweden going from sort of 19th century Sweden into 20th century Sweden, and looking across low and middle income countries at different levels of development. I'm going to comment briefly on the extent to which societal conditions may moderate the impact of birth spacing and potentially also other fertility decisions on offspring outcomes like the risk of child mortality. And then of course just end with some conclusions. So why study birth spacing? It's much less studied than some of these other factors that I mentioned a couple of slides earlier, like family size or birth order, parental age at the time of birth. But it's a very important factor, and demographers, I would say, have always been interested in birth spacing because the timing and spacing of births are a very important underlying component of fertility, affecting how many kids people have and so on. And researchers studying the demographic transition have been interested in that too. And it has policy relevance because ostensibly people have control, or at least some control over when they have births. People can't always get kids exactly when they want them. Some people have trouble getting pregnant and so on. But of course, with modern contraception, people can at least avoid having a child if they use the contraceptives correctly. And studies have shown that you can incentivize different birth intervals, and policies introduced by governments have sometimes unwittingly changed average birth spacing in populations. And so since if these birth spacing decisions do have consequences for child outcomes, it's important to know if we should incentivize certain types of birth intervals, or if we should be careful about using certain policies that might encourage certain kinds of behaviors, which could have consequences for children. So this is a topic which actually has official recommendations from bodies like the World Health Organization, learned societies or learned bodies like the American College of Obstetricians. So the WHO recommends that the time between your most recent birth and when you should become pregnant again should be at least 24 months in order to reduce the risk of adverse outcomes for both the mother and the child. Whereas in the US, the recommendation is for waiting at least 6 months before you become pregnant again. Of course, these recommendations are rather different because the WHO recommendations are directed towards more low and middle income countries. And nevertheless, it's worthwhile, I think, to see that this is something that actually has the policymakers care about birth spacing. And part of the reason why they care is because existing research shows that they can be very consequential for child outcomes. So this is not from my work. This is taken from a meta-analysis paper by Conde Agudelo and colleagues from 2006, on which the WHO recommendation is primarily based. So they looked at 59 studies across low and middle income countries and a few studies from high income countries as well. And what they found, based on the different perinatal outcomes that they looked at, you see here preterm birth, low birth weight, early neonatal death and fetal death, and they looked at some other outcomes too, is that you consistently find a kind of J-shaped curve. So children born after very short interpregnancy intervals, but less than 24 months that I mentioned before, or also longer intervals, say 59 months or longer, so 5 years or longer, they both tend to have worse outcomes on average than children born in a sort of medium interval length. And so that's the basis for that recommendation. In Sweden, some of you in the audience will probably know about the speed premium reform, which was introduced in the 1980s by Sweden. And I think there are some parallel policies. I'm not sure if they have something like that in Denmark, maybe Carsten knows, but in Germany, I believe they have something similar too. And this policy that they introduced in 1980 encouraged women to have their second birth within 24 months of the first birth. Partly, I think in principle, the idea there was so that women would get back to the labor market more quickly. And so they would have their labor market careers less interrupted. And the idea to encourage them was that parental leave compensation in Sweden is based on your income, labor market income prior to having the child. But when you have your second birth, normally you've been less active in the labor market between the first and the second birth. And so your compensation is typically lower after the second birth because you've been earning less. But they said, if you have your second birth within 24 months of the first one, we'll base your parental leave compensation on your income prior to the first child. And so this actually led to a measurable increase, a measurable decrease in birth spacing because of people trying to take advantage of this policy. And in 1986, this was extended to 30 months instead, but this is still maybe longer, okay, than the US recommendations from the American College of Obstetricians, but certainly a lot shorter than what the WHO recommends. And I think it's interesting that from the researchers I've spoken about who were around when they introduced those policies, they weren't thinking at all about whether this would actually have any consequences for child health. So this was just kind of done unwittingly with other intentions in mind. And it's, well, anyway, you'll see whether it had any consequences or not quite soon. So I want to talk a bit about what kind of mechanisms might be driving an association between birth spacing and outcomes for children. So there are a number of different physiological mechanisms that have been put forward. Some of them have greater, sort of a more evidence-based theories. Others are more hypotheses based on kind of a consistent empirical observation, which doesn't have a very good explanation founded in say, medical knowledge or an exact understanding of the mechanisms, but a hypothesis is all that we have. But the theory of maternal nutrient depletion is pretty well established as a potentially important factor linking short birth spacing in particular to worse outcomes for children, like a higher risk of low birth weight or preterm birth, for example. And the idea here is simply that pregnancy and child rearing, particularly breastfeeding, for example, can have a depleting effect on maternal nutrients and resources within the body, and you essentially need some time to recover before you should become pregnant again. And that's the underlying idea there. And so this, if the intervals are too short, then the child born after a short interval may not have all the resources that they need to develop as they may want to. So a key idea here, a key resource there is folate, for example. So that's vitamin B9. And so in high-income countries, often women get prenatal supplements that might include folate supplements. And so this can be done to ameliorate these kinds of problems. But when you have low-income settings with less well-funded or less well-functioning public health systems or medical systems, then you might not have these kind of options available. Very short intervals also mean that it's quite unlikely that there was breastfeeding going on. And there's, even though I'm a bit skeptical about it, and I'm happy to talk about the reasons for my skepticism, there's a large body of research showing that breastfeeding is very good for child outcomes. And so since breastfeeding, if you're breastfeeding, that induces lactational amenorrhea, which means that you're much less likely to get pregnant during that period of breastfeeding. And that weakens over time. So if you breastfeed for a year or 2 years, that effect will get weaker. But certainly shortly after the birth of a child, if you're breastfeeding, it's actually, the probability of becoming pregnant is very, very low. And so if breastfeeding does have beneficial effects for children, then short intervals are also indicative of the parent's child-rearing behavior, if you see what I mean. And this, so this is going to be worse for the older sibling of the two in any kind of sibling dyad. Breastfeeding can also be relevant if we're thinking about a relatively common behavior in low-income countries, though not in higher-income countries, which is breastfeeding pregnancy overlap. So in the case where mothers have been breastfeeding their baby for a long time, lactational amenorrhea will be less effective in preventing an additional pregnancy. And this may mean that they're pregnant as well as breastfeeding the other child, the older child, which means that there's lower quality breast milk, and also the mother is less likely to have recovered from the previous pregnancy, leading to worse conditions for both of the children. you might also be wondering, these hypotheses or theories are based on or focusing on short birth intervals. So why should long birth intervals have negative effects for child outcomes? So the research shows birth intervals longer than 5 years tend to lead to worse outcomes. And some of this is just because longer intervals seem to be associated with worse maternal health outcomes. They increase the risk of preeclampsia for mothers, which is a leading cause of maternal mortality, particularly in lower income settings. But one of the theories for this is so-called physiological regression. And there isn't a very good, this is based more on observational data than anything else. And the idea here is that when the mother gets pregnant for the first time, her body goes through a number of adaptations. The hips widen and some other physical changes occur. And because the body is sort of adapting to the first pregnancy, this is believed to be part of the reason why firstborn children have a higher risk of low birth weight and preterm birth compared to later-born children. So the second-born child, if it's, let's say a couple of years after, the female body is still sort of adapted to pregnancy. But if you wait much longer, say 5 years or longer, some of those physiological adaptations to the first pregnancy, they start to regress to a pre-pregnancy state. This is the theory for it. And so for that reason, children born after long intervals will have a similar risk of preterm birth or low birth weight as say, firstborn children. Naturally, as you might imagine, there are also some potentially important social or environmental mechanisms. So one of these that's talked about frequently in the literature is the so-called resource dilution hypothesis. And the idea here is simply that it's a simple idea that when you have more siblings, finite resources of parents are shared amongst more children. And so each child's going to get less. And the key aspect here when you're thinking about birth spacing is the fact that the early years of life are probably, and the evidence suggests that it's a particularly sensitive period. And so if there's very short intervals, it means, let's say the firstborn and the secondborn they're having their parental resources, time, attention, and so on, distributed between them when ideally they would get all the parents' attention. And so this is going to lead probably to worse outcomes for both of the children. Another potentially important aspect of this is that research shows, as those of you who are parents probably not that surprised, is that if you have multiple closely spaced children, this tends to be more stressful. And so rearing children who are close in age, who are very small, having multiple toddlers, for example, may lead to less than ideal parental care. And not to say that it should be bad, but it's just not as good as it might be if you had all your attention focused on just one, for example. And there's also some literature that shows that even in high-income countries like Norway, for example, parents who have multiple closely spaced births actually have worse health outcomes themselves later on, potentially as a consequence of this kind of, experience. Another factor, which is varies depending on whether we're talking about low-income countries or high-income countries, is the transmission of infectious diseases among siblings. If we're talking about low and middle-income countries, it's much more likely to be, this is mainly likely to be bad, of course, because if we're talking about dangerous transmittable diseases, it could even have a fatal effect on children. And so some studies show that there are certain birth intervals where, I'm actually not completely clear on what the mechanism is there, but if there are intervals of 2 years, the transmission of infection between siblings is supposedly increasingly likely compared to very long intervals, for example. In higher income countries, it might even have an opposite effect because there's research that suggests that, what you probably all heard about, it's called the hygiene hypothesis, the idea that actually some exposure to mildly infectious diseases actually has some kind of protective effect to the extent that it helps people to build up their immune system. So this probably is quite conditional on the disease environment that people are being raised in. So totally different between, Sweden and Nigeria in the 1950s or something like that, right? But a potentially really important factor in thinking about how birth spacing may be associated with outcomes for children is to think about the role of selection and statistical confounding. And this is something that I'm going to be returning to throughout the presentation. And the idea here is simply that birth spacing is not sort of randomly distributed across families, partly for the reasons that I mentioned earlier. People have some control over the timing and spacing of births. So there's abundant research showing that birth spacing is not randomly distributed across families or across parents. For example, high SES parents in some cases space more closely to avoid career disruptions in high-income countries. It's also possible that parental fecundity, which is the way it's used, that term is used in demography, is to describe the ease with which people get pregnant and that kind of underlying latent potential for having children, fecundity. Long intervals may be due to low fecundity because people have trouble getting pregnant. And if having difficulty getting pregnant is associated with some kind of underlying health problem, this could explain not only why a woman has a long interval between a child, but also why, there could be a correlation between her health and the health of the child or something like that. And so you could induce this kind of correlation. Another potentially important factor is that the experiences that parents have with raising children are likely to affect their decisions about when to have the next child. And so if you're, the child that you have now has behavioral problems or maybe some health problems, it may be that parents decide to wait longer until they have the next child, until the problems have resolved themselves or become more manageable or something like that. And so, yes, this is also quite difficult to deal with in the models, but this is a potentially important factor affecting when parents have any additional children. And there's research out there that also shows that, parental happiness in general and the experience after childbearing affects the timing for the next birth. More speculatively, I mentioned that parents have at least the ability to prevent themselves having a child by use of modern contraceptives. So it's also possible that spacing behavior could be related to planning or organizational skills to some extent, which could be correlated with child's educational outcomes as well later. And the reason I mention that is because, so this slide is based on a study by Alison Gemmell and her colleague using US data, and they found that most short birth spacing is unwanted or mistimed. So not that people would not want to have a next child at all, but at least that having a child just then was not planned. And this is also true for very long intervals as well. Very short intervals and very long intervals tend to be unplanned. So in the US, short birth spacing is also more common amongst teenage mothers. It's more common amongst larger families. In larger families, it's more common in low SES families amongst African Americans as well. And the only kind of exception to this pattern of general disadvantage associated with birth intervals in the US is that they also found that older married couples were more likely to have short birth intervals. But this seemed to fit a pattern where they had delayed having their first child until they were, say, 35 or older, and then they planned to have a shorter birth interval because they were pursuing what I would call like an accelerated fertility schedule, where they were trying to have the number of children that they wanted to, despite having started childbearing at a later age. So these would have counteracting effects just on aggregate, but nevertheless, I think it shows quite convincingly that birth spacing is not random at all. And so a big problem is how to address this kind of selection and confounding. And so the approach that I've been using in the work that I've been doing with colleagues is a sibling comparison analysis, or in the literature, this will normally be called a sibling fixed effect analysis. And the idea is to share children who share the same, ideally the same mother and father, but at least the same mother if the data is only available to look at sharing the same mother. And the idea here, even though it's not a perfect solution, is that you can control for a lot of these kind of factors. You know, whatever factors are correlated, whatever factors are similar about your parents, you share them both. And so if those factors are driving later health outcomes, later educational outcomes, later socioeconomic attainment, for example, you're netting out the effect of birth spacing by comparing kids who share those background factors. That's the underlying idea there. In practice, it's done by looking at within group deviation from the mean. And we can talk about that later if you want to hear more. Of course, importantly, kids share 50%, full biological siblings share 50% of their genes as well. And so what we do in these models is we also adjust for factors that vary between siblings. So birth year, parental age at birth, for example, the birth order. So adjust for things that vary between siblings systematically and net out the stuff that we can't observe by comparing siblings in the same family. So that's the approach that we've been using to try and isolate the effects of birth spacing. So the data that I've been using is from a wide range of countries. I think you've seen me flash this kind of map in the earlier presentations I've given at SCAS. For some reason, Finland's colored in here. Actually, there's no Finnish. I'm not going to show you any results from Finland, so that shouldn't be there. But the rest is more or less accurate. So I'm going to show you results based on Sweden, some data from the US, which I'll talk about in a couple of slides, and also data from the red countries are countries that are included in the demographic and health surveys. So I'll be talking about work that we've done using data from about 77 countries and looking over time, comparing siblings. So with the Swedish multi-generational register, I just want to give you, so I don't have to talk about the data each time when I present the results from our findings. I'm just going to give the background on the data now, and feel free to ask me any questions about any of it. So the Swedes in the audience, and probably everyone who's been here for the year also knows as well. I saw there's some audience members outside of Sweden, so I'll just mention briefly. Everyone in Sweden who's living here for at least a year is supposed to get a personal identification number, and this is for administrative purposes. So it's a purely administrative function, but in practice it also enables great research for demographers and epidemiologists and other social scientists and so on. And so what it means is that it's de-identified, of course, for when we access it, but it allows information about individuals to be linked across different registers. So an individual's, basic background information like their birth year, their sex and so on can be linked to tax data, their income from a variety of sources, their educational levels, graduation from school, their GPA, and so on, civil status changes, death, even prescription registers in certain periods. So the availability of these data vary according to what specific register you want to talk about. The most basic things go back, for over 50 years or even longer. Some things like the prescription register are only available for much shorter periods. But the point is, this is based on full population data. And the key thing in here is also the multi-generational aspect of the Swedish register data. And so the idea here is that for each individual, at least if you're born here or if you migrate with your family, is that you have the information not only on the individual ID, but also the two parents' IDs. And if you have information on the parents' IDs, it's possible to link people to their full kin network. So not only their siblings, but because the parents can also be linked to their parents, you can link to grandparents, to cousins, and so on. And so this is essentially, the reason I'm mentioning this is because this is what allows us to do this kind of sibling comparison that I mentioned before. Because we know whose people's siblings are. The other data set that I've been using from the US is a very unique data source, which is not representative of the US as a whole, but it's very powerful to the extent that it represents where it does represent, which is the state of Utah. So Utah is nestled in there in the west between Colorado and Nevada and some other states there. And they have this very unique for the US data set, which is a mixture of genealogical data sources, which are actually collected and maintained by the Church of Jesus Christ of Latter-day Saints, which is the Mormon Church. You may know it better by that name. And in the 20th century to modern vital registration systems. And because it's linked through a mix of census data and birth certificate data, we also have information on people's parents. And so because of that, it's also possible to link people to their siblings. And this data actually, it goes back even before the 1750s to the very first it includes Native Americans, it includes the pioneers who went into Utah, and it's really incredible. But what we're going to be using is just from the 20th century, because at least for now. So what I'm showing you in this presentation will be from the 20th century. And I've mentioned now these demographic and health surveys. So we use the data collection on this is ongoing, but when we ran these analyses, we used surveys collected up to 2014 because we started the study in 2016 or so. But it continues, and it's ongoing now, funded by USAID and some other funding sources, I think. So we're using data from 77 countries based on over 200 surveys, and we put these all together. And so these surveys are really remarkable, and one of the only, they're the best, but also one of the only sources on demographic data in many of these middle and low-income countries. And the data that we have on births and child deaths is based on women's retrospective fertility histories. And so in practice, the way that this data is collected is that they will ask women if they have had any children. They'll ask them, how many children you've had? Okay, 5. When was the first one born? Did the child die? If it died, when did it die? And so on. And so we have this kind of, for the purposes of doing the birth interval analysis, we have data on when the children are born and when they die, if they die. And so we're able to link siblings within the same mother, and we're able to, look at how long the birth interval is. We're able to control for other factors, and yes, look at infant or 0 to 5 mortality. Okay. Did I show this before? Maybe. So this is just to give you another. I'm not going to show that slide because it's just a bit too much. But if you're interested to ask about it, we run these analyses not only for the pooled data, but also by different regions. These are based on UN geographical designations. They're kind of arbitrary, of course, because why is South Africa with Namibia but not with Mozambique? It's there's not always a very good reason, but nevertheless, it's just a way of grouping countries together. But nevertheless, this is the way that we did it in the end. So I'll talk a bit now about the empirical findings, finally. So I'm going to go through first results from contemporary high-income societies, looking at outcomes measured at various stages of the life course. So early in life, kind of in early adulthood too, socioeconomic attainment, and then also mortality. I'm not going to show the results from everything because they fit a broader pattern. And so I'm going to show just a few examples. And I think I have extra slides at the back, which I can share if you want to see results for a specific outcome that I didn't show. I'm also going to show the results, which I think are really cool, but not by me, but by a colleague at Lund University who looked at how this changed over time. I mentioned earlier going from 19th century Sweden into 20th century Sweden. And then I'm going to show the results, which were co-authored with that same guy, Joseph Molitoris in Lund, where we did a paper together using the DHS data, looking at how things change over time across low and middle income countries. So just picture this as a very kind of crude abstraction of what research exists across different stages of the life course and across low, middle, and high income countries. And so you have this little 3x3 matrix, and more or less this is the research that's been done here. So there's research existing on outcomes measured early in the life course across low, middle, and high income countries, But if you want to look at longer term outcomes, it more or less only exists for high income countries, partly primarily due to data availability. So the one exception is there's a little bit looking at height by age 15 in low and middle income countries, but yeah, it's not enough for me to sort of fill in the box, if you will. So as I mentioned before, a meta-analysis of research on this topic found that so I'm talking here again about that meta-analysis from 2006 by Conde Agudelo and colleagues, 59 studies, and they found this J-shaped curve where short and long intervals were associated with worse perinatal outcomes of various sorts. And so until recently, this was more or less the existing research landscape looking at early life outcomes. And so it was kind of universally believed that short birth intervals were bad for infant outcomes. And because of the existing literature that has linked these poor perinatal outcomes like low birth weight or being born small for gestational age, that's SGA, or being born preterm. So basically epidemiologists and economists and other social scientists have linked these kind of poor early life perinatal outcomes to poor long-term outcomes as well. So kids born with low birth weight, for example, are more likely to have lower earnings in adulthood, have a lower educational attainment, lower cognitive ability score where those things can be measured. And they're also associated with worse kind of health profiles later in life as well. Obesity, cardiovascular disease, and so on. And so it was kind of also universally assumed, or at least part of the picture, that, okay, short birth intervals lead to like low birth weight and preterm birth. And since those things are associated with poor long-term outcomes, that must be, yeah, low birth intervals kind of flow through this mechanism maybe, their negative effect on long-term outcomes. And so other research, mainly from the 90s actually, or in some cases even earlier, found that short birth intervals or high sibling density, where the overall sibling group was closely spaced, showed that, yeah, these kinds of intervals or sibling groups of high density were associated with lower test scores, low cognitive ability, and lower likelihood of making educational transitions like going to college. So that's based on data from the US. And there's also some research that, not very much, I never wanted to make much of this, but some research showing that short intervals were associated with worse mental health outcomes, like a higher risk of schizophrenia or depression. But yes. And so, if we go back to my ugly graph, then it looks like basically short birth intervals are associated with worse outcomes in high income countries at various stages of the life course. So the kind of earth-shaking, at least in this birth interval literature, paper was by Stephen Ball and colleagues using data from Western Australia, where they were, as far as I know, they were the first ones to do this kind of sibling comparison, controlling for these shared family background factors to look at this. And they basically found that when you compared kids born to the same mother, birth intervals weren't associated with preterm birth or low birth weight or being small for gestational age at all. And these findings were also replicated in Canada and Sweden, and kind of suggested that actually maybe what was driving these negative effects of birth intervals all along was disadvantaged families. So it's not that, it may be that kids born after these intervals do worse, but it's not about the birth interval at all. It's because certain types of families have long or very short birth intervals. And so that's what's driving the association between the birth spacing and these negative outcomes, perinatal outcomes in this case, but maybe also longer term outcomes. The picture has been complicated by the fact that data from the US comparing siblings in the same family doesn't go along with that. It shows that short and long intervals are associated with preterm birth and low birth weight. It's unclear if this is due to, I mean, the US does have higher infant mortality rates, at least compared to the Nordic countries, for example, and a lot of Western Europe. So there could be some kind of context. Or of course, like the US medical system is very different from what you find across most of the EU. Something could be driven there. They also found this in the Netherlands, but this was a kind of unusual study in that they conditioned on the first birth being a preterm birth. And so they were selecting on mothers who had already had like a poor perinatal outcome. So it's a bit hard to fit that into the same picture because they conditioned the population, the study population, and they condition on that in a very kind of different and important way. But as a result of these series of studies coming out, I'm just giving another plug for the policy relevance of this question. The Centers for Disease Control and Prevention in the US said that, further studies are needed now to assess whether interpregnancy intervals are independently associated with adverse maternal and infant health outcomes, or whether they're just being driven by basically statistical confounding or omitted variable bias in these models. So now I'm going to show the results from some studies we've done, analyses we've done using the Utah population database and Swedish register data. So something that's important to mention here, and I can come back to it and happy to discuss it later as well, is that we look at free child sibling groups. And the reason for that is because if we're going to do this kind of sibling comparison that I've been talking about a lot, is that we need at least 2 observations of birth intervals within the family. So if we just had like a 2-child family, then they would have the same interval. There'd be no variation within the group from which to draw any kind of association between the spacing and the long-term outcomes. So there's no within group variation. So when we look at free child families, though, we have 2 different birth intervals. So if we look at the preceding birth interval, so for child free, it's this time, let's say that's 2 years. And for child 2, let's say that's 5 years. So we have a 2-year interval and a 5-year interval, and we can use that data to see if the outcomes for child 3 or child 2 vary according to the length of the birth interval that preceded them. That's the idea there. But of course, aggregated and averaged across all families. So that does mean, of course, that we don't look at 1-child families. To me, that's not problematic at all because there are no birth spacing in 1-child families, and so it doesn't make sense to even really talk about birth spacing in a 1-child family. But it does mean that we exclude 2-child families. But I'll come back to this later. So what we found in Utah was actually, we did this with data over the period 1947 to 2016, separately by cohort groups, 10-year cohort groups where possible, 6 or 7-year ones for the latest cohort. And we did a pooled analysis as well. And the blue line is where we compare families where we don't do this kind of sibling comparison. So we control for some important background factors, but we don't do the sibling comparison. And the orange line is where we do the sibling comparison. And so our results are consistent more or less with the other study from the US, at least to the extent that we found that short birth intervals are associated with a higher risk of low birth weight in this case. And we found the same when we looked at preterm birth as well. So what we don't find is that long birth intervals are associated with worse infant outcomes, but short birth intervals are. Though this is primarily at the very shortest intervals. So 9 to 12 months, that means the mother got pregnant basically, immediately after the first child. And then also 13 to 18 months. So it still means that there was a very short interval before the mother became pregnant again. After that, more or less, birth spacing doesn't seem to really matter for this risk of low birth weight or preterm birth. In Sweden, we did a similar analysis where we also looked at some kind of socioeconomic variation and variation by maternal country of origin. And when we do the sibling comparison, actually more or less we find something kind of similar to what we found in the US. This is actually based on interpregnancy intervals rather than the birth intervals. But what we found was that it was only the very shortest interpregnancy intervals. So if the interpregnancy interval preceding the child was only 0 to 6 months, then there was a higher probability of, in this case, low birth weight. And so up here, this translates into more or less a 25% higher probability of low birth weight. And if we look at preterm birth, it's even about a 45% increased probability of did I say preterm birth before? In this case, it's preterm birth. So about a 45% higher probability of preterm birth. So short birth intervals are bad for perinatal outcomes in Sweden, but only the very shortest intervals, I think it's fair to say. If we look at longer term outcomes, I'm using data from a wide range of cohorts across the 20th century. So in Sweden, for example, for mortality, we look at cohorts born 1938 and 1960. For education and socioeconomic attainment, we looked at cohorts born 1960 to 1981. So these cohorts vary, but it's mainly according to the availability of the outcome variable, not kind of selecting on, what we want the results to show, of course. So some things like the military conscription data is only available for certain cohorts, or the mortality data, it's just not really meaningful to look at, or at least because deaths are so uncommon in Sweden before a certain age, we basically had insufficient kind of statistical power to look at cohorts born after 1960. So I guess I didn't show this before, but this is just to give you an idea about how birth intervals are distributed in the population and what you tend to find. So this is for Sweden. What you find is that intervals between, well, say 2 to 4 years are the most common. So 2.5, 3 years is the most common birth interval. And actually this kind of birth interval distribution in general looks remarkably similar across different settings and in different time periods, including historical periods, but they just tend to be a little bit shorter in some lower income and historical periods, but the distribution has just shifted to the left. So we look at these different outcomes for Sweden and using data from Utah as well. So here are some results for Sweden for educational attainment. And here what we see, so I'm going to show, these are the results from, on the left-hand panel, the length of the preceding birth interval, on the right-hand panel, the length of the subsequent birth interval. And the red line is the results from analyses where we don't compare siblings in the same family. The blue line is the one where we compare siblings in the same family. And so this red line is reminiscent of that J-shaped curve that I was showing you before from that meta-analysis, right? So kids born after short birth intervals or very long ones, they tend to have lower educational attainment. So at the most extreme, for example, so very short intervals are associated with about 0.25 years lower education. That's about 1/10 of a standard deviation. If you look at very long intervals, there was a much larger association there, approaching about 4/5 of a year of education. But when you compare kids within the same family, this is more or less wiped out completely. Again, supporting that idea that actually this association between birth interval length and outcomes for children is probably primarily driven by some kind of unobserved parental characteristics. And we see a similar story here if we look at the length of the subsequent interval as well. So I think I'm going too slow, so I'm going to slide through these next slides kind of quickly because they show a similar pattern here. So for income, for example, we find a very similar thing. More or less when we compare siblings within the same family, there's no real association there between birth interval length and children's outcomes. The same if we look at an outcome like height as well, for example, using Swedish military conscription data. And it would be the same story if we use some of the other measures from the conscription data, like measures of physical fitness or some of the BMI measures as well, for example. Using data from Utah, it's actually a remarkably similar story as well. So if we look at the fixed effects, the sibling comparison analysis, that's the orange one. Basically, when you compare siblings in the same family, the probability of attaining a college degree, but also doesn't vary by birth spacing, again suggesting that these patterns are driven by the family of origin rather than the birth interval itself. And the same if you look at occupational attainment. So this paper by Joseph Martolis, my colleague in Lund, was a very interesting study from 2017 where he showed, using data from the Stockholm region, that birth intervals, the effect of birth intervals on the risk of infant mortality or child mortality basically diminishes over time. And so in the historical literature, you find a similar pattern of results to what I was talking about before, where short intervals are associated with a higher risk of infant mortality. And you find that in northern Sweden, but also in Quebec and in the United States where historical data is available. But if you basically, as you look over time, so Joe was looking at this period between 1878 and basically about 1920. And what he found was that the marginal effect of a longer birth interval, the marginal beneficial effect of waiting longer got smaller and smaller. So waiting longer between intervals the beneficial effect got smaller and smaller, suggesting that some kind of, social and economic development, improving public health conditions and so on, seems to negate the negative impact of some of these fertility behaviors or fertility decisions. So what happens now if we look at contemporary low and middle income societies using that DHS data that I've talked about? So again, this is not from our study. This is just like a common finding from the literature. This is a paper by Shea Rutstein, who's, one of the most experienced users using the DHS data, where he did a global comparison looking at how birth intervals were associated with, I think in this case, infant mortality, 0 to 1 mortality across countries, and found this clear pattern, which I've alluded to before, where short intervals are associated with a higher, in this case odds ratio, but a higher probability of death in the first year of life. So we used the DHS data, but so the question that we had remaining here was, given this previous research that had done the sibling comparison, suggesting that maybe these patterns were being driven by actually shared family factors, family background factors rather than the birth interval itself. Maybe that's also going on in low and middle income countries. And so it was kind of an open empirical question if we would control for these shared family background factors, whether we would wipe out the negative effects of birth intervals as well. And so, this is just a distribution of intervals in these low and middle income countries. It varies quite a bit between countries, but this is the dark line, solid line is the mean there. And so what we're doing with this data is we're not only using the DHS, but we're also linking these DHS data to aggregate level on kind of macro indicators of economic development. For example, infant mortality rates, total fertility rates, life expectancy, or the Human Development Index. And we link those for country cohorts. So like a child born in 1990 in Nigeria, we link that child to an indicator of the Human Development Index for that period for that country, okay? And we match the estimates that we get from our models for the impact of birth intervals on, say, infant mortality to that development indicator. So the results that we find from our main effects for these birth intervals are very consistent with the results I showed you before from Shea Rutstein's work and many others as well. And it doesn't matter if you do the sibling comparison. That's the fixed effect, the orange line again. Basically, shorter birth intervals are associated with a much higher probability of dying in the first year of life. And doing the sibling comparison actually doesn't make super much difference from if you don't do it. Suggesting that in this case, actually maybe these physiological factors like maternal nutrient depletion, for example, may actually really be driving this association between birth intervals and this high risk of infant mortality. But what we found also was that this varied a lot by maternal educational level. So as you go from mothers, in some cases in these countries, women, well, not just women, but many people, especially in the earlier periods that we're looking at, may essentially not have any education. But if you go up to primary, then secondary and tertiary, then you can see that the gradient of the association between the length of the birth intervals and the probability of dying in the first year of life gets flatter and flatter, suggesting that it's not a simple case of birth intervals always increase, short birth intervals always increase the probability of infant mortality, but it's clearly moderated by socioeconomic resources and contextual conditions and probably access to healthcare facilities and so on. And we find a similar thing when we look at these educational patterns across high mortality contexts, or if we look at them across lower mortality contexts in the DHS data. So all of these kind of point to this moderating effect of social conditions, both at the meso level, like in the immediate family, but also at the macro level, based on social conditions more generally, public health infrastructure, and so on. And this is kind of the final results that I'm going to show you before I jump to some conclusions, is that we looked at these, we did what I said before, which is we took the estimates for each country cohort for the marginal effect of increasing a birth interval by 12 months from 12 months to 24 months to indicator of development. And basically what we found was that the percentage difference, the percentage difference in the benefit of increasing a birth interval by 12 months gets smaller and smaller as you get to higher levels of development, here indexed by the society level infant mortality rate. So basically, as you get to lower and lower levels of infant mortality, increasing a birth interval has a smaller and smaller benefit for your child's survival. And you find the same story if you look at other indicators like the Human Development Index. So birth intervals matter less and less at higher levels of development. And that's more or less what I was saying there. So there are definitely some limitations of what we've been doing here, and I'm really happy to talk about those too. And I think the nice thing about having this very diverse audience is that you probably all have a very different perspective that we don't always get when we demographers maybe talk amongst ourselves. So sibling comparison approaches necessitate a focus on sibling groups with 3 or more children. They may be different, of course, from sibling groups with 2 children. The reason I personally haven't been very worried about whether that's biasing our results very much is because at least when we look at so the results from, say, Sweden or Utah, where we're looking at the longer term outcomes, what we find there is a null effect. And so if anything, some of these mechanisms that I was talking about before, maternal nutrient depletion or resource dilution between siblings in the family, those, if anything, should be worse in larger sibling groups, I believe, because you would have, more shortly spaced births, or you've got more siblings to share the resources amongst. And so the fact that we find in high-income countries, especially looking at longer-term outcomes, that birth spacing doesn't seem to matter even in large sibling groups suggests that it probably doesn't matter in 2-child sibling groups either. So for the most part, these analyses don't control for time-varying factors within the sibling group, which is another important thing. So we can do some, and we had done some robustness checks looking at what happens if we control for parental income to the extent that varies between siblings and so on. At least in high-income countries, this doesn't matter. In the low-income countries, we unfortunately don't really have this this opportunity. So there's other things that we basically don't have data on that we can't control for that could also be correlated with birth interval length and child outcomes, but I think the extent to which these are driving the results, I think it's probably limited in the high-income countries, and in the low-income countries, it's part of a bigger picture where short birth intervals are actually really associated with negative outcomes. And so they probably contribute something towards that too, but it's hard for us to identify the extent to which it matters. So just a final conclusion, or slide or two, those born before or after short or long intervals typically do worse on all measures of child health, adult health, and long-term socioeconomic attainment. But it's not, at least in high-income societies, it's not due to the birth interval itself. It's due to whatever shared family background factor is that's driving that. In low-income countries, it's a different story. It is probably being driven by that birth spacing. And so we see that levels of development do seem to matter a lot. It matters a lot in low-income countries, but these negative effects seem to be neutralized by development. And so if I'm just going to finish on this slide, if I was, this is my traffic light system, I would say in low-income countries, it's bad. In middle-income countries, it's better to be avoiding short intervals, but it's not as bad as it would be in low-income countries. And in high-income countries, short birth intervals don't seem to have negative consequences for offspring outcomes, more or less, unless you have these very exceptional short birth intervals and you're talking about perinatal outcomes like low birth weight or preterm birth. Okay.